Hello everyone. Today we will talk about permutation and combination. So in this video we will cover the concepts of permutation and combinations with example and concept of basic principle of counting with example and condition. And next video we will solve the questions related to basic principle of counting and derivations of formulas of the permutation and combination. So without wasting time, let's start our topic. Okay, to understand the permutation and combination, let's take an example. Suppose there are three persons. This one and this one and this one. So first understand about permutations. This one is A, this one is B, this one is C. Any persons, random person. If you want to click their photos by using camera, how many different poses can we make by arranging their position? By exchanging their position, how many different poses can we form? If we click a photo from here by using the camera, this is also a pose of photo. Another pose can we form if we fix A at their position and exchange the position of B and C, then there will also a pose form. So if A is fixed at their position and B and C exchange their position, so C and B here. Now we click a photo from the camera, then also one pose form. Is it? Another way we can say that if I fix B at first position and swap the position of A and C, then A, C. This is also a pose of the photo. Is it? If another way, if I again fix B and swap the position of A and C, then C, A. It is also a pose of the photo. If again I say that if C fix at first position and swap the position of B and C, so means B is here, A is here. This is also a pose of the photo. Okay. Again, if C fixed here and extend the position of A and B, then what will form? A and B. Again we make a picture. So there is total how many pictures can we form? How many poses we can form? There is only 6 different poses. 1, 2, 3, 4, 5, 6 poses. By using 3 people at a time, we can make 6 different poses. It means what? If we exchange, here we are arranging the position of A and B, C. Here we are arranging the position of A, B and C with order. If we arrange A, B, C such that A is first, B is second and C is third position. So we click in photo, it is one pose. If I fix A and swap their position order change. If I change the order of B and C, a new pose. If I fix B and exchange the position of A and C, this is also become a pose. Hence we can say that here we are exchanging or arranging the objects with order, where order is important. So simply we can say that permutation is the arrangement of object where order is matter. So this is an example. By using this same example, we are going to understand about combination. So let's suppose this is same peoples are here. A, B, C. In combination, if I say how many groups in such that group must be contain 3 people. So how many ways can we select these 3 people to make a group? We have only one choice, only one way. Either use first select A and second B and third C. A, B, C. This is a group. Again, if we say that not I will select first B I will select first B, then A, then C. So B, A, C. This is also a group. You say not, I select first C, then A, then B. This is also a group. But note that what I did say that, I say that how many groups can we form by using these three peoples at a time. In a group, three people must be present. So in this group also same peoples are here. In this group also same peoples are here. In this group also same peoples are here. So are these groups are different? Not. These are the same group. Group 1, 2, 3 are the same group, because same group means if the same peoples are in a group, then group is same. That's why these all groups are same group. It means only one groups can we form. There is no matters of order. Is there order matter? No. Although first we select A, then B, then C, and again we first select B, then A, then C, there is no matters. There is no matters of order. That's why we can say that combination is a selections of objects without their order. Is it clear or not clear? Okay. I hope the definition of permutation and combination should be clear. So let's write some difference between permutation and combinations. Okay. In conclusion, what can we say that permutation is arrangement of object with their order, where order matter. Permutation is arrangement of objects where order matters. Where order is matter. If we change the order, there will be another arrangement become. That's why order is matter. But in combination, there is no order. Selection of group. Combination means selection of objects without order. Clear? Okay. This is the definition and meanings of combination and permutation. So another point we can write, note that I said that in this video we will cover only concepts of permutation and combination. There is no derivations of formula, and question solving. This is only concept based video. Okay. So to understand the relation between permutation and combination, we will take a basic example. We will take 2-3 examples. We will see the one greatest relation between permutation and combination. So let's suppose if I say that there is a letter A. This letter may be anything: apple, ball, cat, anything. But in math, in general, A is a constant which may be anything in our daily life. Okay. So this is a letter A. If I say that how many groups can we form by using this letter? You can say that there is only one group can form. Only one group. That is A only. Only one group can we form. If I say that, I again say that there is a letter A, same letter here. How many way can we arrange this letter A? This is only one way. Only A. Either A you put here or here or here. There is only one arrangement. So this is also one arrangement. A. Understand? Again, if I take two letters A and B, how many groups can we form by using these two letters at a time? Make a group in that group must be two letters. So there is only one group, A and B. Only one group, A, B. Same way, if I say that there is AB, in how many way can arrange them? A and B, how many way can arrange? There is two way, AB and BA. This is two arrangement. So two arrangement. There is one selection, two arrangement. One selection, one arrangement. Okay. I again say that there is three letters A, B, C. How many groups can we form of three letters? There is only one group. By using A, B, there is only one group, A, B, C. These three letters, if we taken at a time, then one group can be formed. Same way, A, B, C, how many arrangement can we form? A, B, C is arrangement of itself. Again, we can say that if we fix the position of A and extend the position of B and C, C, B, it is also an arrangement. Again, if we fix B at first position here and extend the position of A and C, A and C. Again, extend the position of AC, so C, A. Again, fix C at first position, then BA. Again, C fixed and AB. There is 6 possibilities. What can you notice here? Can you notice here anything? What can you notice from here? By using these 3 examples, what can you notice from here? I am noticing that if there is one object and selection of this one object is one way. If there is one object, same objects, if we arrange them, then one way. This is also same. So in one object's arrangement and combination is same. Similarly, for two objects, combination of AB is 1, but their arrangement is 2. What means what? If we select AB, then we will make AB only. Again, if that selected AB, if arranged, so that will be arranged by two way. It means what? It means what? In combination there is only selection, but in permutation, selection plus arrangement. Here, in second, we can say that if we select ABC in one way only one group can we form. If we, after selecting, if we arrange this ABC, then there will be 6 possibilities. It means what? Combination is only selection, permutation is selection plus arrangement. Can we say like this? So what can we say? This is only selection, but it is selection plus arrangement. From this example we can prove it.